All right, this is 11.8, the last section in chapter 11, and it is about spheres. So we're going to kind of break it into the pieces, and then we're going to move into volume and surface area like we did for cones. So a sphere is a solid. I'm sure we have an idea of what it is, but the official definition is a solid with all points equidistant from the center. So essentially you have a center, any point you draw radiating out in every direction, not even 360, but because it's in 3 dimensions now, they're all going to be the same distance from the center. A sphere chord, now remember with just a regular circle, a chord went from one point to another. A diameter went through the center. And the radius went from the center to the edge. So these are similar, but on a sphere chord is still a segment, but it's inside the sphere. With both endpoints on the sphere. So if you can kind of imagine that this isn't laying on top of it, it's kind of cutting right through it. It's inside. A sphere diameter is just a special sphere chord that contains the center of the sphere. And the sphere radius is a segment with one endpoint at the center and the other endpoint on the sphere. So those are just kind of the pieces that we're going to be using for these formulas, so we just want to make sure we know what we're kind of discussing. Now, the surface area of a sphere. The formula, I can't spell sphere. This formula is pi r squared, just like the area of a circle, multiplied by 4. So how do we get that? Well, if you kind of imagine a baseball and what they use to cover that, if you unwrap a baseball, this is what you get. Which essentially, it's a little squished, but it's 4 circles. And the radius is still the same, it's just now it's from the center of the sphere to the edge. This is the part in class where if I had you, I'd ask you for different examples of a sphere. So I will just write down what my class last year came up with, which was basketball, an orange, the moon. Now there are round objects like eggs or watermelons, but those are kind of oblong, they're kind of squished. So a sphere is perfectly round. So find the surface area of each sphere. Well, the surface area, you need the radius. So here we have the radius, which is great, because it's 4 pi r squared, so 4 pi 8 squared. Put that in your calculator. 804.25. Now, surface area, so it's square units, and these units are inches. Now, for this one, they did not give us the radius, they gave us the circumference. So, circumference is 2 pi r. So we can use that to find the radius to move forward. So we have 12 pi equals 2 pi r. Divide by 2 pi on both sides. You get left with, the pi's cancel out. 12 divided by 2 is 6. So here, my surface area for pi r squared, we found the r is 6. That gives us 452.39. Make sure you are testing this in your own calculator to make sure you can get them. Now, this is kind of working backwards. Find the diameter of the sphere. Well, the diameter is 2 of the radiuses, so we can find the radius. And what did they give us? They gave us the surface area. So, surface area equals 4 pi r squared. So the surface area they gave us is 20.25, pi, 20.25 pi equals 4 pi r squared. We divide both sides by 4 pi. The pi's cancel out, which is great, and you just have 20.25 divided by 4 is 5.0625. I'm putting so many decimals because that's exact. That's not going on forever. It stops right there. So how would you find r squared? Well, r squared is 5.0625. How would you find r? You would take the square root of both sides. And if you take the square root of that, so your radius is 2.25. So remember, it asked for the diameter. So you multiply that by 2, and the diameter here is 4.5. What are the units? Well, this is in centimeters squared, so it'd be centimeters. All right. And now go to 11.8 part 2, and we will work with volume.